In this video, I'm going to teach you how to solve polynomial equations. Now, the idea behind polynomial equations and solving them is that we're going to use our analytical methods of factoring to reduce these into simpler problems. So when I look at this first one, I'll get 0 is equal to x cubed plus 3x squared minus 13x minus 15. Now I'm going to think about the three different methods we have for factoring. We've talked about using polynomial long division. We've talked about quadratic nature. We've talked about factoring by grouping. If I looked at factor by grouping, I could certainly group these two, but these don't have much I could factor out, and these don't have much I could factor out, so that's probably out. I could look to do quadratic in nature, except for this does not look quadratic in nature. For 1, I have 4 terms, and for 2, I do not have just two terms as exponents, where 1 is double the other. So there I'm left with polynomial long division. And if I'm going to use polynomial long division, I need to know at least one factor already. So to do that, I'm going to use the rational roots theorem. If you don't know what I mean by rational roots, either Google it or take a look at the video I posted on the website. So for rational roots, we look at factors of this guy. So that would be things like 1, 3, 5, and 15. So factors, the P could be 1, 3, 5, and 15. And Q here, Q is just 1. So my possible roots are all my P's divided by Q's. And since Q is 1, it's not going to actually change any of those. So it'll be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay. So I'm going to use those possible roots, and I have to actually find out which one of those is. So set up, I'll say x. If I call this my function f of x, actually I don't even need to do that. Let's just write the polynomial there. So I set up my table. I'm going to plug in some of these possible roots, and hopefully I'll get lucky and find one early on. So I'll start off with 1. Okay. If I plug in positive 1 here, 1 cubed is 1, x squared is 1 times 3 is 3. 13 times 1 is 13, so I get minus 13, and then minus 15. I get that just by substituting 1 for x. 1 plus 3 is 4, 4 minus 13 is negative 9, and negative 9 minus 15 gives me a negative 24, so it tells me no. X equals 1 is not a root. I'll try negative 1. Let's keep working my way up. Negative 1 cubed is negative 1. X squared, if it's x is negative 1, negative 1 squared is positive 1. 1 times 3 is 3. Plug in negative 1 for x, I get negative 13 times negative 1, which is a positive 13. And then I'm subtracting 15. Let's add these together. Negative 1 plus 3 is 2. 2 plus 13 is 15. 15 minus 15 is 0. So yes, I have found a root. Means that x equals negative 1 is a root. Okay. So now how I'm going to turn this into a factor now is that means if I plug in negative 1 to some factor, I'm going to get 0 out. So it must mean that x plus 1 is a factor. And that can be a little point that can catch some students here, is that negative 1 is the factor, but x equals negative 1 is the root, but x plus 1 is the factor. Reason why? If you plug in negative 1 for x, negative 1 plus 1 is 0, and that's kind of what we're going for. So now I go up here, I'm going to do long division. I'm going to factor x plus 1 out. x cubed plus 3x squared minus 13x minus 15. Right. Do long division, I need an x squared. I get x cubed plus x squared. Subtract these guys now. That gives me, see, those cancel out. 3x squared minus x squared gives me 2x squared. Drop down minus 13x. Compare x and 2x squared, and what I need is a 2x. 2x times x gives me 2x squared. 2x times 1 gives me a plus 2x. Subtract. Those guys will cancel. Negative 13x minus 2x gives me a negative 15x. Drop down the negative 15. Compare x and negative 15x to give me a minus 15. Minus 15 times x is minus 15x. Minus 15 times 1 gives me a minus 15. Those guys are the same, so it comes out to 0. Okay, so now what this tells me at this point, let me give myself some room here. All of this tells me here is that 0, which is equal to x cubed minus plus 3x squared, 13x minus 15. I can rewrite that as these two factors multiplying each other. Okay. So this must mean, I can look at this, that either this factor is equal to 0 or that factor is equal to 0. Now look at that and I see a quadratic. I think maybe I can factor that right away. Product sum. Product negative 15 and the sum to 2. Go with our factors. I think 1 and 15. Well, let's see. They're probably going to be at least one going to need to be negative. I think we come up with 5 and negative 3. 5 times negative 3 is negative 15. 5 plus negative 3 is 2. So I can factor this quadratic term as x plus 1 times, let's see, x plus 5 times x minus 3. Okay. So you use rational roots to find a root. I turn that root into a factor. I've divided that factor out. I was left here, and then I factored the quadratic to have a completely factored version of this expression. Now what that tells us is I have something times something times something, and I'm getting 0. And the only way to multiply things together and get 0 is if at least one of those things is 0 itself. So what I can do is I can say, well, maybe this term is 0. And if that term is 0, well, let's just write out what I said. In that term, x plus 1, it could be 0. Additionally, maybe that term's not 0. Maybe it's this term. So I'll write x plus 5 is equal to 0. Alternatively, it could be this last guy. X minus 3 is equal to 0. And those are all very, very simple equations to solve now. Subtract 1 from both sides to get x equals negative 1. Subtract 5 from both sides, get x equals negative 5. And then add 3 to both sides to get x equals positive 3. And those are my 3 solutions to this equation. Okay. So again, the process here was I identified a appropriate method to factor. In this case, it was using rational roots theorem to find a root, turn that into a factor, and then use polynomial long division to break that down. Once it's broken down, I could factor these smaller problems, the quadratics now, and then now I can set each one of these factors to 0 and solve. And if I plug any one of these 3 numbers into this equation for x, it should make it balance out. It should make the right side equal to 0.